They are asking the electric flux in this question. The value of electric field intensity is given in terms of I cap and j cap. I cap and j cap, when you write the values, that's called rectangular components. So the electric field is given in terms of rectangular components, I cap, j cap. The value of E0 is given as 2 into 10 raised to 3. The surface area is given 0.2 meter square parallel to the YZ plane. We are supposed to calculate the electric flux. Grade 12, basically you need some topics from grade 11, like the addition of vectors, vector addition concept, and even vector product. There are two types of products, scalar product and cross product. Here the electric flux comes under the scalar product. So just a brief idea, not in detail. The electric flux or even the scalar product before that. The definition for scalar product: A dot B is equal to AB cos theta. Vector A dot vector B, this is called dot product or scalar product. That's equal to magnitude of A, magnitude of B, and cos theta, where theta is the angle between A and B. So darkened, like A is in bold letters, B also. This means it's a vector. These two lines means magnitude of A, magnitude of B, no direction. And theta is the angle between the two vectors. This is the basic way you find scalar product of two vectors if magnitude of A, magnitude of B, and angle between A and B is given. Okay, they didn't give any angle. They only given in terms of IJK. So we have another way to represent that. This method is only applicable if the vectors are given with their magnitude, values are given, and the angle between A and B. If the vectors are given in terms of rectangular components, like in terms of IJK, we have another rule. If A is given as something into I cap, something into j cap, like this, E0 3 by 5 into I cap, that is AX here, 4 by 5 E0 j cap, that's AY here, there is no Z component. If the vectors are given in terms of I, j, k components, then the dot product can be calculated as just the multiplication of x component of first vector with x component of second vector, AX into BX, then plus the y component of the two vectors, AY into BY, plus the Z component of two vectors, AZ into BZ. So just multiply the coefficients of I, coefficients of j, coefficients of k, and add on. If anyone is absent, you can take it as 0. So this is only if the vectors are given in terms of rectangular components, means I cap, j cap, k cap. So this is a basic concept at least you need for applying in this particular question. Now when we come back to electric flux definition, the electric flux definition is electric flux phi equal to EA cos theta. Is exactly same as AB cos theta. So you can write AB cos theta as A dot B. That means electric flux EA cos theta can be written as vector E dot vector A. If EA and angle between E and A is given, we can use this format. That's not given here. It's given in terms of IJK, rectangular components. So we should resort into this particular format. So flux will be equal to here AX BX, it's E and A, so EX AX plus EY AY plus EZ AZ. X components product, Y components product, Z components, and add all the three. Now if you check E value, the values are given as 3 by 5 E0 along I cap, 4 by 5 E0 along J cap, there is no Z component. And the area is given as 0.2 meters square, they didn't give any I cap here. So area is also vector. To understand the direction of area vector, the area vector is always normal to the surface and outwards towards observer. So if you take the x, y, z components, this is the x, y, z axis. And now the base is called the x, z plane. This is the x, y plane, and this is the y, z plane. Here it's given the area is parallel to the y, z plane. This is a y, z plane area. So this is the area. If you are observing this area, the area vector will be towards the right, because the area vector is always normal to the surface and outwards. So this is along the x-axis. So if it's y-z plane, it's along the x-axis. If it's x-z plane, along the y-axis. If it's y-x plane, it will be along the z-axis. So since it is y-z plane, it's along the x-axis, I cap. That's why it's written 0.2 meter square along the I cap. I cap is a unit vector parallel to x, j cap is parallel to y, and k cap is parallel to the z-axis. Now we have the Ex is 3 by 5 E0, Ey 4 by 5 E0, there is no Ez, so this term will be 0. But area vector only have x component, so Ax is 0.2. There is no y component. Y component is 0. So this part also will disappear. Here both are absent. Here E is there, but A is absent. A is 0. So the product will be 0. So the phi will be only Ex into Ax. Now you can substitute the value of Ex and Ax. Ex is the component along with I, 3 by 5 E0. Ax is a component along with I, 0.2. For E0 value you can substitute what's given in the question, 2 into 10 to the 3. Now it's simple calculation. So 110 you can take, this will be 2. So this will be 100. So 2 into 2, 4. 4 into 3 into 100 by 5. For 12 into 100 by 5 is 20. So 12 into 20, 240 volt current. That's a final answer. So keep an idea of the dot product if the values are given in terms of I, J, K like rectangular components.